Testing is a tricky business.
Our objectives were to develop protection criteria for 3 and 4 drums high.
A good fire test looks at a single variable, and it controls all the other variables and fixes them. A good fire test program looks at the problem and designs the tests so that you can answer as many variables as you can.
We're also trying to create a credible worst-case scenario.
A warehouse fire can be deadly. It can be destructive and can cost lives and property. It is in industry's best interest to minimize the risk of catastrophic loss in a fire. In August of 1998, a series of fire tests was conducted at the Southwest Research Institute in San Antonio, Texas. Experts from various industries convened in Texas to form the technical team. Their goal, to determine how high 55-gallon steel drums containing highly flammable liquids, could safely be stored under certain specified conditions. The results of the tests would be the basis of recommendations made to the National Fire Protection Association, or NFPA. NFPA 30 is the standard defining protection for containers filled with flammable and combustible liquids. As a code, it is incorporated into many state and local fire codes and OSHA regulations. NFPA 30 by itself is not a regulation. If adopted by state and local jurisdictions, it becomes law. Today, NFPA allows nominal 12-foot-high storage of 5-gallon relieving-style steel pails. Yet for relieving-style steel containers greater than 5 gallons and less than or equal to 60 gallons, NFPA 30 does not allow storage more than 2 drums high, or nominal 6 1/2 feet. Relieving-style containers tested in this case were steel drums fitted with nylon plugs. Nylon has a higher melting temperature than other plastic resins, such as polyethylene or polypropylene, which are also available in closures. Nylon was selected because it was important to test the most difficult case. In order to modify an NFPA 30 so that it recognizes increased storage in a protected scenario, full-scale fire testing of steel drums had to occur. Drums filled with product and stacked in a typical storage array. The testing occurred at the Southwest Research Institute Department of Fire Technology, a highly respected organization devoted to fire research and testing.
The evaluation program we're conducting here this week is to evaluate the storage of steel containers using relieving-style bungs under different levels of sprinkler protection. A test matrix is set up to evaluate different levels of protection, going from the highest level of protection with incremental steps to lower levels of protection. This is a very unique test, but it falls well within the range of the capabilities of this facility.
The tests were deemed successful. They demonstrated that steel drums stored 3 and 4 high could be protected.
What we proved is companies who store flammable liquids in steel drums will be able to store these drums 3 drums or 4 drums high now. Currently they're limited to 2 drums high under protected criteria in NFPA 30. None of the drums ruptured or came close to rupturing. That's very significant because remember, one of the things we're trying to validate in this test program is the utilization of a relieving style drum. And these drums were all equipped with nylon bungs, and they did what they were supposed to do. They would fuse or melt and vent any buildup of pressure within the drum.
The results of the tests could have a far-reaching impact for industry and on safety.
Our existing warehousing would be allowed to go to a large increase in percentage of storage as opposed to having to invest in more warehouse locations.
Our primary interest in this series of fire tests is to help ensure the safety of our employees, the life safety of our employees, and of any potential emergency responders that might be involved in responding to a fire at one of our locations or at a customer location.
Fire responders are concerned about violent failures of non-relieving style containers in fires. The pressure vetting capabilities of the tested plugs allow relieving style containers, properly protected, to be exposed to a fire longer, thus giving firefighters more time to respond to a fire.
I'd feel a lot more confident knowing that these drums are the self-relieving style.
FlexCon is one of their primary directives has always been safe operations. We're constantly reviewing our requirements for operations, the types of materials stored, and any improvements we can make to the employee safety and the facility safety have always been a leading issue for all the FlexCon locations around the country.
With increased storage, users can take better advantage of warehouse utilization, while never losing sight of the focus on safe storage. The experts assembled for the technical team included professionals from the chemical, steel, and insurance industries, as well as fire safety engineers and specialists in fire suppression systems. Funding for the test was provided by a variety of corporations and organizations. The testing efforts were coordinated by the Steel Shipping Container Institute.
There are many facets to a fire test program, and successful fire test programs will tap into a collective body of knowledge that can only be offered by a group of people coming from varying disciplines who understand the problem from different perspectives. And it allows the program to move forward with a much higher degree of success.
Industry groups have started to get together with insurance groups and other groups to form a consortium, pool their resources, and create a fire test program to look at a specific type of problem. That adds a lot of credibility to a program, because what it brings to the table is not only fire protection expertise, which is necessary to build a good, credible test program, but it also brings in the expertise of those who actually are using the products and understand what they may or may not really do in industry in real life.
The tests were conducted over a period of 3 weeks. Each test followed a standard procedure. Pallets of steel drums filled with 100% heptane, a Class 1B flammable liquid, were stacked in the test warehouse. Each steel drum was fitted with nylon pressure-relieving style 2-inch and 3/4-inch plugs. Selected drums were attached to transducers, which measured internal pressure, and thermocouples, which measured the temperature of the container. The data was fed to a computer and was monitored by the technical team in the control room. The team visually observed the tests through monitors attached to remote cameras. For each test, 55 gallons of heptane were injected into the array. The first 2 tests demonstrated that a flow rate of 2 gallons per minute produced the worst-case scenario. Therefore, this rate was used during the remaining tests. The heptane was remotely ignited. The first group of tests evaluated the existing protection criteria in NFPA 30. A 2-tier high, nominal 6 1/2 feet, storage scenario of 72 heptane-filled steel drums was protected by a suppression system consisting of a sprinkler discharge density of 0.3 GPM per square foot using 3% AFFF foam. Another 2-high storage scenario was protected using water at a sprinkler discharge density of 0.6 GPM per square foot. In later tests, extra-large orifice and pendant sprinklers, both easily obtainable from sprinkler suppliers, were used. In incremental steps, the test progressed to more challenging combinations. The discharge density of foam water was varied. After the three-tier test passed, using AFFF at a discharge density of 0.6 GPM per square foot, the team tested the same scenario, but with a lower sprinkler density, 0.45 GPM per square foot. This passed as well. The original plan was to test a maximum of 3 tiers, but since the 3-high or nominal 10-foot array successfully passed the testing criteria, a 4-tier nominal 13-foot 144 steel drum scenario, that is nearly 8,000 gallons of heptane, a doubling of the storage height allowed in the 1996 NFPA 30. These steel drums were tested at a discharge density of 0.6 GPM per square foot using AFFF through ELO pendant sprinklers. And this test passed the stringent criteria. 6 sprinkler heads were set off. No severe jetting or drum bulging was observed.
Well, as we're watching the fire test and analyzing the results after the fire test, we're looking at things such as ceiling gas temperature, ceiling steel temperature, number of operating sprinklers, the amount of damage to the drums, and the type of burning that we were witnessing on the videos, such as, a pool fire versus jet flames. And these are all significant items and are used in the decision whether or not a test was a pass or a fail.
The combination of an effective sprinkler system, which used either water or foam water, and relieving style containers, made the tests a success. The test data produced results that could allow users the option of using 2-high storage with water at a discharge density of 0.6 GPM, or 2-high with AFFF foam at 0.3 GPM, both of which are in the current code, or 3-high with AFFF at a discharge density of 0.45 GPM per square foot, or 4-high storage with AFFF at 0.6 density.
The NFPA 30 committee members now have the option of adopting this protection criteria, integrating it into the code, and allowing warehouses to use protection criteria that will protect 3 and 4 drums high.
In August of 1998, a testing milestone occurred at the Southwest Research Institute. A testing milestone which provides a greater balance between safety and utilization of warehouse space. Steel containers, when fitted with nylon or other plastic closures designed to relieve internal drum pressure during a fire, can both reduce the risk of loss in a fire and improve storage efficiencies.
All right, 1 second.